So if you were given a question like this, sketch a graph of the quadratic function on a test or quiz, you could use any technique that you would like. Probably a lot of you would change it into the standard form by completing the square so you could find the vertex. And standard form looks like this, right? And if you change it to this form, P and Q would be the vertex. You'd know your A value, so you know you'd need to go over, for example, in the first one, your A value would be -2. You'd go over 1, down 2, over 1, down 6, over 1, down 10, and so on. And that is one way to graph it. If you can factor it, we can now use another way to graph it. So what we're going to do with these examples is use the factoring technique to graph them by having our x-intercepts. So here for A, if you factor out the -2, oh, maybe we can't factor this one. If I factor that out, can I factor x squared minus 5x plus 7? No. So in this case, I wouldn't be able to factor it. So then my only way to sketch the graph would be to change it into standard form. If we could factor it, then we could get our x-intercepts. So for A, I tried factoring out this. I noticed this part can't be factored. So you have to have pretty good control of your times table, because you have to do a lot of mental math quickly to determine, can I factor something or can't I factor it? Now that I know that I can't factor it, I'll probably say I want to go back and change this to standard form. So I'm going to factor that -2 minus 14. I'm going to factor that -2 out of my first two terms and leave space. So now that I've left space, divide this by 2. 5 over 2 squared will be 25 over 4. Again, thinking with this number out in front. When I multiply it by -2, that makes -50 over 4. So I've subtracted -50 over 4 already. So to compensate, I'm going to need to add 50 over 4. 50 over 4 simplifies to 25 over 2. I can now write this as x minus 5 over 2 all squared. 14 is 28 over 2. Negative 28 over 2 plus 25 over 2 will be -3 over 2. And now I know what my vertex is. My vertex is at positive 5 over 2, comma, -3 over 2. Now when I actually go to graph this, this is where decimals might be nice, just to imagine where it is. 5 over 2 is 2.5. -3 over 2 is -1.5. So as far as where that point is on my graph, it'll be right there. Then because our A value is -2, you're going to go over 1, down 2 to find your next points. This is positive 2.5, comma, -1.5. And then you have to go over 2, down 2, and so on. Okay? You need to show your vertex as a key point, and you need to label at least one other point so that you can indicate how narrow or how wide your graph is. So what I did by going over 1, down 2, I could say another point here is at 1.5, because that would be 1 to the left. And if I would go down 2 from negative 1.5, that point would be 1.5 comma negative 3.5. Another point that people like to draw to show width that's easy to figure out, because you can get it from your original equation, is what would happen if I plugged in 0 for x. Can you see from my original equation, if I plugged in 0 for x, I'd get negative 14? And so that tells me that down here, if I extend this down here at negative 14, woo, perfect parabola, my graph is going to go through there. As far as quizzes and final exams and in preparation for your grade 12 exam, anytime you draw a graph, if it continues on forever, you need to put arrowheads on the end to indicate that that graph does continue on forever. Just like you did with lines last year when you drew a line, you need to put arrowheads on the end. You need to make sure that you do that with parabolas as well. So there's part A. Part A wasn't factorable. We started to look to see if it could be factored, and it wasn't factorable. Okay? If you look at the example the textbook has done, what they did is they looked at the discriminant. Remember, the discriminant is what is inside the square root. And something from chapter 3 is you can tell if something's factorable if the discriminant is a perfect square. But in our example here, we would get 100 minus 4 times negative 2 times negative 14, which will be 100 minus 112, be negative 112, or sorry, negative 12, I think, in the end. And if you get negative 12, what does that tell us about a discriminant? There's going to be no real roots, no x-intercepts. Can you see in our graph, can you see that our graph has no x-intercepts? And if there are no x-intercepts, you won't be able to factor it. Because your x-intercepts are when it's equal to 0. And if your quadratic equation is impossible because there's a negative inside, your quadratic equation is finding your x-intercepts or your roots or your solutions or your zeros, whatever word you want to use. If it's not factorable, either there's no x-intercepts, but sometimes you might get a number in here like 32. Is 32 a perfect square? No. But there'll still be 2 real roots. It just means there are x-intercepts, but they're not at nice numbers that you could factor the original equation. Let's look at B. Initial look at this one, you might say to yourself, this is not a fun one to factor, because that 4 out in front makes it difficult. I don't know if it's 4 and 1 or 2 and 2. Maybe I can try factoring it, but if we did look at the discriminant of this one, b squared minus 4ac, b is 12, so b squared will be 144 minus 4 times 4 times 5, which will equal what? 80 minus that, 64. Notice that 64 is a perfect square because the square root of 64 is 8. Because this is a perfect square, it tells us, yes, you could factor this. So it gives you motivation. Now, if I'm factoring this one, and the fact that it starts with a 4x squared, and 4x squared could be 2 and 2 or 4 and 1. Some people just pick one at random and say, I'm going to start with 2 and 2, and if nothing works after trying for half an hour or three days, then I'll switch to the other one, to 4 and 1 or 2 and 2. I don't know which one I had picked first because it's been 3 days ago. Whatever. But in this case, I would probably start with that 5, because 5 can only be 5 and 1 or 1 and 5, but if you start with that, the order doesn't matter. So now I'm going to start with 5 and 1, and I'm going to look, does 2 and 2 work or 4 and 1 work better? And the mental math here says 2 and 2 works better because I've 10 on the inside, 2 on the outside, that makes 12. And they both have to be positive to get positive 12, and I still have positive 5 from my last one, so I know that this works. So I know right away from factoring what my x-intercepts are. My x-intercepts are going to be negative 5 over 2 from the first one and negative 1 over 2 for my second one. So now that I have it in factored form, I can tell where my x-intercepts are. So if I draw that out, again, maybe I'll go to decimals here. This is negative 2.5 and negative 0.5. And maybe you can see it directly from the graph that the axis of symmetry is right here at negative 1.5. If you can't see that directly from the graph, you can add those two up, right? Negative 5 over 2 plus negative 1 over 2 gives us negative 6 over 2, which is negative 3. The average then cut it in half, and you get negative 3 over 2, which is negative 1.5. Now that we know the axis of symmetry is at negative 1.5, you can find the y-coordinate of your vertex. Because all you need to do is plug in negative 1.5 into your equation. Go to your calculator to figure that out. And we get negative 4. Is that right? Yep. Oh, that's such a pretty graph now. Negative 1.5 comma negative 4 is our vertex. And so now when we go to graph this, we know that it looks like this. We could also see from our original graph that our y-intercept is at 5. Because if you plug in 0 for x, that's what you would get. So for this one, in order to graph it, we didn't need to complete the square. But you could still do that as well. We didn't use the fact that the a value says go over 1 up 4. But can you see how it's working? We start at negative 4. If we went over 1 up 4, we would get right to that first x-intercept. Generally speaking, when you're asked to graph, 98% of the time, you're going to change to standard form like we did here, because it always works to graph. Majority of the time, you're going to do that as your way to graph. Very rarely will you factor first to graph it, because it was still a fair bit of work to find out if you could factor it and then factor it. And that amount of time that you're figuring that out, you could have been completing the square and figuring it out that way. However, the time that it is nice to graph it is when the question starts in factored form. So if the question said graph this and it was already factored for you, then that's a good place to use that for graphing. Okay, so questions you can do for this one are 6 and 7. And I'll give you a little bit of time before we do the next two examples.